Grab your pink packet. This is the review for the semester 1 final in pre-calculus. It covers lots of topics. Ladies, quiet please. Look at number 1A, the very first one in the packet. All right. It says factor completely. Yes, we had problems as simple as just factoring. So when they are complicated ones like 1A, 14x squared, you got to look for a GCF first of all. Minus 33x minus 5. Is there anything that goes into all these 14, 33, and 5? No. Therefore, you cannot make it simple, but always look for that because sometimes you'll factor out like a 3 and then everything becomes way easier. All right, since that didn't happen for us, then is there another tip I can give you on this? Well, basically, you just have to know how to do guess and check. That's the only way we require you to be able to do this. So if I'm going to guess and check my way through this, I'm going to go, all right, it's probably 7x squared and 2x, sorry, 7x and 2x, but I don't know for sure. There is another way to do this. It's called the AC method, but it's not very nice either. It makes you do it this way where you go this number times this number, and that would make 90, and then you'd say, how can I take the 33 and divide it up into parts to make it equal 90? Anyway, there is a way other than guess and check is my point, but we're not going to make you memorize it because frankly you'd spend 2 days figuring out the new way, whereas guess and check just takes a while. You eventually just run across the number. This, at least the 5 is nice because you know it's a 1 and a 5, right? It has to be. I just don't know where the 1 and the 5 go, whether it's the 5 in the first one or the 1 in the first one. And then one's got to be negative, one's got to be positive. So I'm just going to throw something together. Seriously, I don't know if this is going to work at all. I'm just going to try it. So the outside is positive 7. The inside's negative 10. Positive 7 and negative 10 don't make negative 33, do they? All right, so this just takes some time, farting around with the numbers. Has anybody got an answer? Ooh, you found it. Mrs. S. What'd you get? Or Ms. S. Plus 1. Plus 1 and the minus 5. I was close. I just had to switch my two numbers around. Now I'm going to check it, make sure you're right. As soon as I got 35, I knew I was close, right? And then the 1 times 2 makes 2. And then, yep, that one works. If you had ever gotten something the opposite of what you wanted, like if this had been a minus and this had been a plus, then you get the exact opposite. Like that would be positive 33x. If you ever get the exact opposite of what you want, then just switch the signs. Plus and minus. Okay. All right. That's enough about factoring. Let's move on to number 2, the solving kind. Well, that's just a quadratic. Why? Because it's got a squared in it. So your two choices on these are factor them, minus 8x. Oh, by the way, I'm going to reset this to plus 3 equals 0. I hope you know why. You'll always want to set your equations equal to 0 to solve them. Now, if it factors, sweet, way easier, done. And if it doesn't, then you do the quadratic formula. Now some people, and I'll share this method with you because some people liked it, I shared it with people last year. If you want to know if the thing will factor or not, what you really need to do is start the quadratic formula, and if you start the quadratic formula with the square root part, if the square root part works out to a nice number, then you can know ahead of time it will factor. It's up to you, but if you wanted to do it that way, you know how it's x equals negative b plus or minus square root, blah, blah, blah. I'm going to start with the square root and go b squared minus 4ac. b squared is 8 times 8 is 64. Minus 4 times a is 4 times c is 3. And 4 times 4 is 16. 16 times 3, 48. And I take 64 minus 48. What's that? Okay, then I'm going to go borrow one from there. What is it? 16? Okay. 50, 64. Yep, good. 16. Ooh, square root of 16. Square root of 16 works out nice. Now you have kind of a dilemma, though. If you've gone this far with the quadratic formula, isn't it easier to just kind of finish with the quadratic formula? Yes, it's true that since that square root of 16 is a nice number, it would have factored in the first place. But it really boils down to, if you're really good at factoring, factor them. It's faster for you then. If you're really slow at factoring, just do the quadratic formula. Because if it would have factored, this number will just work out really nice, that's all. All right, so negative b would be 8 plus or minus the square root of 16 all over 2a, which is 2 to the 4 is 8. So it's really, I've gone this far, I may as well just finish 8 plus or minus 4 all over 8. And so I do it once with plus and once with minus. All right, I think you can take it from there, can't you? All right, so if you haven't already, this was problem number 2a. You can get that one copied to there. All right, let's do a different kind. There's a solving with an absolute value coming up on E as an elephant. Let's look at E as an elephant. 2E. And it says absolute value of x plus 2 over 3, and that one is greater than or equal to 3. So my first step on an absolute value is to break it out of the absolute value. And to do that, you recopy exactly what you see. X plus 2 over 3 is greater than or equal to 3. That is one part of the answer. And then you copy the stuff on the inside stays exactly the same. X plus 2 over 3. And now on the other side, though, instead of a 3, I'm going to use a negative 3. So do you remember what happens if you change the signs? You got to flip it then. So this one has to become less than or equal to. And then I solve those two little equations, and I'll have it. So from here, I'm going to multiply by 3 on both sides. X plus 2 is greater than or equal to 9. And then I'm going to subtract 2. X is greater than or equal to 7. That's one part of my answer. Over on the other side, times by 3x plus 2 less than or equal to negative 9. And I'm going to subtract 2. X is less than or equal to negative 9 minus 2 is negative 11. And then, yes, you could write the answer just like that. If you wanted to, you put the smallest number first. You put the biggest number last. You put the x in the middle like a sandwich. And then you just have to decide which way the signs should go. X is bigger than the 7, so I should go like that and like that. You can do it like that. You can put it all, I'm okay with this or this. Remember, it's a multiple, no, it's not a multiple choice final. Actually, we've changed that. It is a free response final, 32 questions. 32 questions. That's not that bad, but they're pre-calc questions. How many do you normally have on a test? 8. Okay. So it's 4 times as big as a normal test, right? And you only have 2 hours instead of 4 times. So it's not like it's going to be a piece of cake, but anyway. It is scored on the Marzano scale, too, which is good, and that you can get 3/4 of them right, as in 25% wrong, and you can still have an A. Okay? And it's not like by section, you know what I mean? It's not like I got an A in this section, a C in this section. It's all one big final, so you can get 1/4 of them wrong and still get the A. Yes, sir? There are some R2s and R3s. I'm assuming it's 16 and 16, but I am not positive. I would assume so. Okay, any other questions about that stuff? All right, let's move on. So far it's been easy, of course. Let's get to look at number N as in Norman, or Normandale, which is where Norman used to live. Square root of x plus 29 plus x equals 1. All right, first step. You can't do anything until you isolate the grouping symbol. In this case, it's a square root thingy. So I'm going to subtract x from both sides. Square root of x plus 29 equals 1 minus x. Now, how do I get that square root fixed? You square it. You square a square root, it fixes it. Now, here's the classic mistake, though. This part's okay. X plus 29 is as simple as it seems. But on the right side, you'll have a lot of people say, oh, it's just 1 squared minus x squared. No, you have to do 1 minus x times 1 minus x. This is a not complete square, sorry. This is a FOIL thing. You cannot just do 1 squared and x squared. That won't work. And then when you FOIL that puppy out, you'll have a squared in it. And look, Mom, it's a quadrilateral. No, what's it called? Quadrilateral. That's a quadratic. It's a quadratic. And so back to quadratics again. Factor it or complete the square. Or sorry, man, I keep kind of saying complete the square. I did that in higher algebra, so it's messing with my head. So it's either factor it or quadratic formula. All right, moving on. Along those same lines, do you get on letter P? On letter P, I've got a, there's two ways you could do this one. In fact, for math, that's true a lot of times. There's more than one way you could do it, but there's probably an easy way and a hard way. And I personally, and whenever I can, I just want to fix fractions so that, I got this tip from a calc teacher. They just said, if you can just make it so it doesn't have fractions anymore, it's just so much easier. Yes, there's other ways you could do this by multiplying, by doing cross multiplication and that kind of stuff, but just fix it. It's got an x minus 1 in the denominator. How do I fix that? Multiply by everything by x minus 1. So I put one here, and I put one here, and I put one here. And now it won't have a denominator anymore, because that'll cancel that. 2 plus, this has to be multiplied out, x squared minus x equals 5x minus 1. Do you see why quadratics was such an important thing last year? You got another quadratic to solve. You got so many quadratics. All right, so then, oh, you're right, you caught me. Thank you. Oof. Because this was, I really should have put the parentheses around it. I tried to be quick and I paid the price. All right, that's enough help, I think, for that one. Let's flip the page. We've got to get through a bunch of these because the easy ones are easy. Do you recognize problems like number 5? Sorry, that's an S. S is in Samuel. We just got done with that. That's like the thing you just had on your last test, right? But I've said this statement before, see if you can complete it. If you can factor it, you should factor it. So look, does the top factor? I bet it does. Does the bottom factor? It probably does. Once it factors, you'll be able to see a bunch of important points you put on a number line. Okay, and then once you're done with finding your important points in the number line, you got to test intervals. It's just like what you just got tested on. That whole page is. So I think I don't need to probably review that, except a few of you struggled with yours, so I'll let you ask individual questions of me if you'd like. Let's move to number 3A. That'll be a blast from the past. Haven't done that stuff in a while. You get to add, subtract, multiply, divide them, and then the hard part, finding the domain of each of those kinds. There was all kinds of rules for those. That's why I'm here. I get to remind you what they are so that you can get them back in your head. All right. When you add, subtract, or multiply, it is fairly simple. You just take your two domains and you overlap them. Do you remember writing the number lines on top of each other like this? Domain of F and the domain of G. You just overlap them for add, subtract, multiply. Okay. What about divide? Do you remember how to do like F over G? Well, you got your two number lines, but it's not F and G. Well, actually, wait. You do have two number lines, but you have a third number line also. It's F and G. And what's the third one? Something can't be 0, but what can't be 0? Not the composite. Nope. G. That one. See, normally G can be 0. The function standing all by itself could be 0, but when you put the function on the bottom, when the G has to be on the bottom, G cannot be 0 anymore. And you'd overlap 3 number lines for that. Okay, so let's do that one, for instance, for number 3A. So on 3A, my functions are f of x is 2x minus 1, and g of x, I'm going to write that definitely separate, is x squared. Okay, now I'm going to go do my domains. My domain of f is, you remember on domain, you're just looking for things that crash it. So crash it. Crash it. You don't want denominators to be 0, and you don't want square roots to be negative. Remember those? Those are the things you're looking for. This doesn't have a denominator, so I can't crash it. Do you get how this says a domain of all reals? No way to stop that thing. Okay, so this is all reals, so I'm going to use a filled-in number line for that. And then the domain of G, I'll do that in red here, is, can you crash that guy? No, so that's also domain of G is all reals. When you overlap all reals with all reals, surprisingly enough, you get all reals. But there's a third number line because we're doing F over G. So this is all reals. This is all reals. But what would make G into 0? Not what would make G crash, but what would make G be 0? 0. So 0 is the one thing that would cause a problem. So it can't be 0, but it could be everything else. Now the question is, where do all three number lines overlap? They overlap right there. So that's from 0 to infinity. And they overlap on the other side from negative infinity to 0. So 0 is the only thing that would not work in F over G. Yes?
In this subproblem, is there any brackets or so?
There can be brackets. There can be brackets. So like for instance, actually, I can't think of any situations because it's usually parentheses. But math teachers are pretty much trained to never say never. So almost always going to be a parenthesis on this kind of problem. I can't think of another way to do it with a bracket. So what she's saying is if this would be filled in, but if it was filled in, I wouldn't be like noting that point in the first place. Because you don't like fill in, you usually pick the spots that don't work. All right. How about the kind where you do F of G of X? What number lines do you overlap to get that guy's domain? You remember this? Domain of the inside, good. So the domain of in and the domain of the composite, good. Okay, the inside in this case is G. So domain of G and the domain of the composite. Well, if I'm still doing that first problem where it was 2x minus 1, one of the functions, and the other one was x squared. If I put G into x, I'm putting this one into this one. It's going to be 2 and then x squared, because this x right here contains this x squared now. So 2x squared minus 1. So my composite is 2x squared minus 1. There's my composite. So my two domains I got to overlap are domain of G, which was all reals, and my domain of the my domain of the composite. Here's my composite. What's its domain? Can anything crash it? No. So that one's all reals also. So when you overlap all reals and all reals, you get all reals, of course. Why can't anything crash this? Because you have to have a denominator or a square root to be able to have something crash. All right, like when you go on to part B, you got a square root there, so your domain of F. Maybe we should do just that part. For number 3, looking at part B, you've got one of your functions is the square root of x plus 4. How do you do the domain on those again? You always set what's in here and you set it in a little equation, and what do you say about it? X plus 4 has to be what? Greater than or equal to 0, and then you solve that. So the domain of this guy is x has to be greater than or equal to negative 4. That's just the domain. This is just the domain of F. And that means if you wanted to have a number line for that, it would be here's a negative 4 filled in there, going like this. And yeah, that could be a case where it depends if what the other one's domain is that overlaps with it. But this could be a case where we'd have a bracket. All right, moving on. Okay. Let's actually do it. The other one is x minus 2. This was f of x. G of x, I'll put in green here, is x minus 2. What's the domain of G then? All reals, yep. So since it's all reals, where would they overlap? Yep, this would be one with a bracket. I'm glad I didn't say never. Got to watch out for that in the ACTs or any multiple choice test. Always is nevers. Usually answer is usually false. Okay. All right, let's see if we can. I'm going to do one more page or not. Let me check, see if that's reasonable. No, that's plenty to do for tonight. So I'm going to say that if you want to stay on track, you should try to get done up through C3C. And I will start problem 4 on tomorrow's video. So that's all I got for you for today.